Before doing a lesson on solving quadratic equations by using square roots with multiple equations, we're going to review what square roots are. If we have the equation a squared equals 49, what does a squared mean? A squared is saying that we multiply a by itself 2 times. So a times a equals 49. So what number, when multiplied by itself 2 times, gives you 49? There are actually 2 numbers. One is 7. So 7 times 7 is equal to 49. So we know that x will be, or sorry, in this case it's going to be a. So we know that a will equal 7. The other number, when multiplied by itself to give you 49, is negative 7. So negative 7 times negative 7 is equal to positive 49. So a is both equal to 7 and a is equal to negative 7. Another way of writing that solution is a is equal to plus and minus 7. And in set notation, it's written like this. A equals 7 and negative 7. So this here is called set notation. So there are 3 different ways to write the same solution, right? A equals 7 and negative 7, a equals plus and minus 7, and a equals 7 and negative 7. Another way of thinking about solving this same equation, let's use a still. We have a squared equals 49. A is squared, so we want to undo the square by taking the square root. Remember, what you do to one side of the equation, you have to do to the other side of the equation. If you remember, if there is no number outside of the radical, that number is an invisible 2. So we'll put that in red. What happens is that the square root will cancel out with the square and we'll be left with just a, and then we'd say, what is the square root of 49? It's plus and minus 7. Remember, we can write that in set notation as 7 comma negative 7. And we'll go over the last way that you can solve these types of equations. Again, we're going to use a squared equals 49. So right now we have 2 as the exponent. We want to get rid of that 2. In order to get rid of the 2, we multiply by the reciprocal of 2, which is 1 over 2. What happens is this 2 in the numerator and this 2 in the denominator cancels out, and we're left just with a. But remember, what you do to one side, you have to do to the other side. So since we multiplied to the exponent 1/2 on the left side, we have to do that on the right side as well. So 49 to the exponent 1/2, if you put that into the calculator, it's the same thing as saying the square root of 49, which again is plus 7 and negative 7. Positive and negative 7, which in set notation again is 7 comma negative 7. Let's look at numbers 3, 5, and 7 right now. So remember, x squared equals negative 97 would be x times x equals negative 97. For number 5, x squared equals 16 is the same thing as saying x times x equals 16. And for number 7, b squared equals 100 is the same thing as b times b equals 100. So let's look at number 7 first. What number multiplied by itself will give you 100? Well, 10 times 10 is equal to 100. So b is going to equal positive 10. And negative 10 times negative 10 is equal to positive 100. So it's going to be b equals plus or minus 10. Or in set notation, we'd write that as 10, comma, negative 10. For number 5, you'd say 4 times 4 is equal to 16, so x will be equal to 4. And also negative 4 times negative 4 is equal to 16. So it's going to be plus 4 and negative 4. Positive 4, negative 4, or in set notation, you would write it as 4, comma, negative 4. For number 3, two numbers that multiply to give you negative 97. Now think about it. If you have a positive number times a positive number, it's going to give you a positive number. If you have a negative number times a negative number, it's going to give you a positive number. So right now, there is, since we haven't discussed the complex plane, there is no real number that will make this equation for number 3 true. So for number 3, since it's a negative number on the side, there is no number that you can multiply by itself to give you negative numbers, so this is going to be no solution. We're going to look strictly at numbers 5 and 7 now, since we showed that number 3 has no solution. So if we solve it the other ways, we could do x squared equals 16. Remember, to get rid of a square, we take the square root to both sides. Remember, if there is no number on the outside of the radical, that's an invisible 2. So the two 2's cancel out, and we get x equals the square root of 16, which is 4. Positive 4, negative 4. Same thing we do for number 7. We have b squared equals 100. To get rid of this square as an exponent, we take the square root. Remember, if there's no number, it's an invisible 2. These two 2's will cancel out. Remember, what you do to one side of the equation, you have to do to the other. And you get b equals plus 10, positive 10, and negative 10. And the last way we'll solve numbers 5 and 7 is we have x squared equals 16. And we want to get rid of the exponent 2, so we can multiply to the exponent 1/2 to both sides of the equation. Remember, this 2 here and this 2 here cancel out, so we're left with just x to the first, or just x, equals 16 to the exponent 1/2, which is positive 4 and negative 4. For number 7, b squared equals 100. Again, we want to get rid of the exponent, so b has an exponent of just 1. So we have to multiply by the reciprocal of 2, which is 1/2, to both sides of the equation. So this 2 and this 2 will cancel out, and we're left with just b to the first, or b. 100 to the exponent 1/2 is going to be positive 10 and negative 10. So those are 3 different ways you can solve one-step squared equations.